to store a name. Sorry, a name is equals to. So let's give it my name. It's Tiffany, and then we have to print. So in Python or in
Just a minute, please. Sorry for interfering. Some cannot see your screen, so let's just check first of all if everybody can see your screen. No, don't change because I can see. But yeah, you just stay there. Let's just check if they can see now. Anybody having a problem with viewing the screen? Elizabeth, you can't see the screen. I don't know whether you can see it right now. I suggest maybe you exit and then you come back again. Probably it's your internet connection. So yeah, because I can see her screen. All of us, can we see her screen? Yeah, Lewis can see your screen. Anybody else? If you can see the screen, please just give a thumbs up if you can see the screen. If not, let us know. Yeah, Ronnie can see the screen. Catherine Mungohai can see the screen. Kate can see the screen. So I think Susan can see the screen. We are good. So Elizabeth, please just exit and then come back again. Bobby can see the screen as well. All right, so let's proceed on Tiff.
Okay, so when you're declaring a variable, like I want to declare a variable, so I'm creating a container to store information. So this is the container. The container is called name, and the information is my name, so Tiffany. So in any programming language, if you want to output something, you use the word print and just print my name, and then so it will print my name. So that's how you declare a variable. You can also declare.
Sorry, Tiff, just a point of correction. Some programming languages they don't use the printer, so not all. Some programming languages. So just to clarify, so that they don't, some of us don't get confused. Okay.
Okay. Yeah, some programming.
Yes.
Languages.
Yeah.
So we can also create another variable, like we can say student underscore name is equals to, say, Tiffany, and then print student, and then when you run it, it will now print Tiffany. So this is different from this one because I've put this inside multi-line comments, so it won't run. So the code that's being run is this one. So this is what we call the snake case. As I said, if you want to print long name variables, you can use the snake case, use the underscore. So that's the first one, and then we go to rules in naming a variable. So the rules in naming a variable, we said you can start with a capital letter, like my name is equals to Tiffany. Okay, let's not use the string right now. Let's use max. Max is equals to 10. Then print max. So it will print 10. So this, we are just looking at the rules for naming a variable. You can have a capital letter. You can begin with an underscore. Like let's say max is equals to 20. Print underscore max. So this one will print the variable, the data 20. So you can declare a variable like this. You can declare a variable with an underscore, and you've already seen you can declare a variable using a small letter as the first one. So we can try and we can try and use the wrong syntax for declaring a variable, like let's say 1 max is equals to 30. Then print 1 max. Sorry. So you see it's bringing out an error. It says invalid decimal literal. So when declaring a variable, you must start with a capital letter or an underscore or a small letter, but you can't use the number to begin the naming your variable. So we can move on to the next one. Is everyone okay? Is someone stuck? Is everyone okay?
It seems they are okay, Steve.
Okay. So we move on to the next one, dynamic typing in Python. Dynamic typing, like I said, in Python, you don't have to declare like this data that I've inputted is a number or it is a word. You don't have to declare it. It automatically knows. So like let's say name. Let me just use name. Name is equals to chief. So when I want to check, it already knows that the data I've inputted is a string. I said a name is a string, a number is an integer, a decimal is a float. So it already knows it's a string, but we can check print type name. So you see it's showing that the class is a string. So like I said, it dynamically knows the type of data you've inputted. We can use the one we used above. Max is equals to 40. Enter. Print. We are checking. Okay, so the type, this type, it is used to show which class or which what nature the data in the variable is. So like we here, the name TIFF is a string, which is a name is equals to a string. So the name TIFF is a string. It's stored in the container. A container is a variable called name. So we are using the word type. So for someone who, like, if you're showing someone, so they ask you what type is the word TIFF, you use the word type, and then you put in the container name, so the variable name, which is name, and then it will print string. So we can also check for the integer, and then we just run it. So the first one, which was TIFF, will be a string, and the second one, which is a number, is now an integer. So yeah, so we don't have to automatically you don't have to automatically declare that this is a number, this is a string, unless it's in a function, and that's a whole another topic. And then we have global variables. So like
Before you proceed on TIFF, maybe if somebody wants to know what is that type, because it's a keyword, but you've used it. So what is it? What type? What is it basically?
Okay, so type is a function that's used to show which class the data is in. So we have integers, we have strings, we have float. So this type is used to show which class a data is in. Like we already saw for the word for 40, it's in the class integer. For the name TIFF, it's in the class string. So type is used to show which class a data stored in a variable belongs to. Not only in a variable, but there are other places, but it is used to show which class it is. So if it's an integer, if it's a string, a float, a boolean, it is used to show which class it is in. Okay, so we got to global variables. So global variable.
Yeah, I like the way you've explained this, Tiff. However, I wanted just so that somebody knows that it's an inbuilt function. So that word inbuilt is very, very important, because they might think that you've just come up randomly with it. No, it's an inbuilt function, and function comes bundled with those functions. So those are keywords. All right, proceed on.
Okay, so we have global variables. So like I said, a variable is a container that is used to store data to be used inside the program. So we have global variables, like global containers, universal containers that store data. And the data inside those universal containers will be, if it's global, it's universal. So it is used throughout the program, like it can be accessed throughout the program. Like we can say the water, like maybe in a company, the data that is shown to the people is also accessed to the employees in the company. So, and the local variables, it's only accessed to the local employees. Like maybe you're ordering something from an online store, like let's say Jumia, you can see the products that they are selling. Also, the manufacturers and the company can see what they are selling. So that the data, which is the product that they are selling, that's what we call like the global variables, like the data that is accessed throughout. But the local variables, this include the way shipment is done and the names of the employees. They're only accessed by the company. So you should put that in mind. I'll use that to explain the local variables. So the global variables are declared outside functions, and like within the program, like we can say y is equals to 10. So here I'm going to use a function to explain. So define function, like let's say explanation. And inside the function, we can see global y, and then print. Yes, we can say y is equals to 5. Print y. Then it's very very oh okay. So this is one of the ways I'm saying global variables are accessible throughout the program, which is also inside a function. So this is how we define a function. And inside the function, you can only use a global variable inside a function when you use the word global. Okay, so global is also a special name, like the word define, like the word def. It's a special name. It's a Python sensitive name that is used to tell the Python compiler or the program that this is what you're supposed to do. So the word global, it is used to in the function. We are going to say inside this function we are going to use the variable y, which is global. So we change y into 5, and then we print y, and then we call this function. So y initially was 10, but we changed it from y, we changed to 5. So if you have a container and you have data inside the container, you can change it. You can change your name, you can change anything. So we are changing the data inside the container y from 10 to 5, and then we are printing it. So it will give out the output 5. But if we don't um, if you don't use the word global inside a function, let's just copy this. So if we don't use the word global inside the function, this is the output. Let me just, yeah. Let me, so it's just printing 5. So, okay, maybe I didn't use the right explanation, Papa. Let's not use
No,
this
no,
one.
you are. I think you're doing it the other way around. You just use the same explanation. So what essentially you are saying in here is that because you see, when you use global y, that means that the function that is the y at 22 can now be seen by the entire program out of the function, because when we are globalizing the function y in here. But you see, if you print let's see, let's remove 25, 26. Yes, comment them out so that okay, go back to the okay, so comment 19. So comment 19, just 19 only. No, just comment 19 only.
Oh, okay.
So if this so if we print y right now, just print y now. Okay, we are getting 5, huh? We are getting 5. I think let's wait a minute, because y. Okay, can you print out of the, or you're printing out of the function, right? Okay, yeah, it's correct. It's correct, because now y can be accessed out of the function. But try remove the word global, then we see which y will be accessed, and also uncomment 19, so we see which y will be. Yes, so let's, yeah. So now okay, go back. We are printing, we can see now we are printing both the local one and the global one, because now the program, we've made, we are not supposed to see this inside here, because this is, or we are seeing this inside here because of this print here, 22. Comment print 22, and then just comment that, line 22. Okay, then print, let's see, because we need to see, yes, now we see 20. Go back to the program. Now we see 20 because we initially we had this local variable y is equal to 5 being made global, and that's why we were getting 5. But now it's only accessible to the programs, to the function only, but it's not accessible to any program out of the function. And that's why we are seeing, we are printing, when we print y is equal to 5 is not getting printed. We are getting y is equal to 20 because y is equal to 20 is global. But if we want to make y is equal to 5 global, then we use the keyword global. I hope that makes sense. Steve, you can continue.
Okay. So I hope you've understood that. We'll go to the local variables now. Uh, we are using the same notion from the local variable from the above here, which is, let's use y is equals to, or maybe let me just declare another one here. Let's say x is equals to x equals to 15. Okay, so x is equals to 15. This is this also we are looking at local variables. So the local variables are only used inside functions, like the way we've seen here. So this this y is the variable that is inside the function. Like I said, so the information from the company about the workers and shipments will only be accessible to the staff, to the people who are inside the company. So when you're outside the company, you cannot see that data. So this is the same notion, the same analogy we are using here. So when you're outside this function, you can't see the y. Like let's say if you want to, let's not use this print here. We can use this print here, and then we run it. It says error traceback, and y is not defined. Y is not defined because we have called it outside the function. So that is why we call it a local variable. You can only access it when you're inside this function. But when you put it inside this function and we run it, it will print 5. Is that okay?
Yeah, very good, Tiff. Very good.
Okay, so the last one we're doing is type conversion. We can have like let's say a number is equals to, let's say, 40, but we don't want, so when you like I said, when you put it into brackets, it is considered a string. But if we don't want it to be a string, we can convert it into an integer, which is a number. So when you want to convert it, you have to give it another container. So in the container called number, it knows that it's only going to store the string. So you have to give it another container to say from the container number, you have to store, you convert it from that type, that class type, and once you've converted it, you store it into this container. It's like you're sorting. So you have, let's say you have beans and you've cooked it. So when you've cooked those beans, you remove them and put it in another container, and you leave the ones that are uncooked in the first container. So we give it another, we declare another container or variable, which is, say, let's say converted. And when we give it converted, and we want to convert it into a number, which is an integer, we just use int and then the variable number. So this is what we are telling our program is, you take the data that is inside the container called number, and you convert it into an integer. So the data inside the number is a string. You convert it into an integer, it will become a number. And once you convert it, you have to store it in another container called converted. And then, so for us to know if it's working, we just have to print, and then we just check the type. and then we run it. Sorry, just give me a moment. Let me just. When you run it, it will give out the class integer. So let's put this into comments, and then I show you what it is. So for this, we can print type and then the number. So when we run this, you see the class that is showing us is a string. But when we convert it, it will give us an integer. So like I said, we are telling the program to take the data that is inside the container called number. You convert it into an integer, which is so the container which has a string, you convert it into a number and you store it into a new container called converted, and that's how we check the type after we've converted it. Yes, that's all I had for today. Has everyone understood?
Anybody with a question for Tiff? Looks great so far. Good job, Tiff. You've done an incredibly good job at explaining to us variables. Yeah, so I like the analogy that you used about the local variables and the global variables. Like the global variables are like, for instance, you're working in a company, call it maybe Safaricom. So in this company, only the employees and the staff know what is inside the company, like what those the nitty-gritties about the functionalities of the company. And so people outside, like customers, don't know what's happening. So we can say local variables are like, like let's say the details, what's happening inside the company are enclosed within that company, and they're not exposed to the entire world. So only the local guys, they understand what that is. So we can liken that to a local variable. And now when it comes to a global variable, that means the outside world, that's outside of Safaricom, they have access to that information. So that's global. That's what it basically means. Yeah, thank you so much, Tiff. You've done an incredibly awesome work. And yeah, you are a very good teacher. You are very, very clear. Yeah, so I'm sure you all agree with me that she's a very good teacher. All right, so next, Lewis, are you ready? I want Lewis, I think you are explaining functions. If you don't have any other question, please. Okay, Lewis is ready. If you don't have any other question, I think we can proceed on. There's much more to do in terms of variables. We are just trying to recap, like we are reminding ourselves, especially for those people like Elizabeth and any other person that's still having issues with variables, so that you can remind yourself. People like Alan, if in case you have an issue with variable, just to let you know that you can remind yourself. We are recording this, so don't worry. You can, and we will put it on YouTube, so you can listen to it later on. See if you can listen to yourself and see how you've done. All right, Lewis, go on now.
Hello guys.
Yes, hello Lewis.
Yeah, so I'll be taking you through Python functions, and we'll go through why use a function, creating a function, calling a function parameters, default parameters, return statement, using the asterisk to pass multiple arguments, nested functions, Python inbuilt functions, and the pass statement. Yeah, so definition of a function. A function is a block of code which only runs when it is called. You can pass data known as parameters into a function. A function can return data as a result. Why use a function? A function, you just write it once and you can use it multiple times. Modularity, you break large code into smaller manageable parts. Readability, easier to understand and maintain, and you avoid repetition. Yeah, so to create a function, we use the keyword def. Example, to create a function that creates someone, this is how you create it. So I'll just illustrate. Use the keyword def and then you must watch the indentation. Yeah, and then you call the function. So that is how you make a function. Yeah, hello stranger. So functions, they can use they can return values. For example, this function you can see here, define my function x, it returns 5 multiplied by x. So it will multiply 5 by 5. Oh, you have to print. This is what you're calling the return keyword. I don't know. I think I skipped some.
Make it big, Lois. Make it big.
Oh, yeah.
Yeah. Good.
Oh, I skipped the parameters, sorry. Functions can accept parameters that modify their behavior. By default, a function must be called with the correct number of arguments, meaning that if your function expects 2 arguments, you have to call the function with 2 arguments, not more, not less. Yeah, so the arguments, for example, here, this A and B. Yeah. So then there's the default arguments. If you call a function without an argument, it will use the default parameter. Let me illustrate that. Yeah, so this is how we initialize the default arguments. You use the equal sign, and then you initialize it to a variable. Yeah, so if you don't place any argument, it will use the default. And if you, for example, say Nakuru, say welcome to Nakuru. So using the asterisk to allow multiple arguments. So for example, if you don't want to limit a user to the number of arguments you want the user to input, use the asterisk. Yeah, that one. I'm using an inbuilt function called sum. Yeah, so as you can see, the sum is 20. Yeah, so you can input and there's no limit to how many. Yeah, so use the asterisk. And then next we go to nested functions. These are functions inside other functions. And here is an example. Let me put it for you. It just means a function inside another function. So when you call the outer function, it will call the inner function. Yeah, hello from the inner function. This none, I think it means we've printed 2 times. Yeah. So next, I'll be going through Python inbuilt functions. So these are, for example, the print function, the sum functions, the length function, the sorted, and the type. This prints whatever value the user enters here. The sum finds the sum, and the length finds the length of, for example, an array or a dictionary, a tuple. And the sorted sorts the whatever value you've entered according to maximum or minimum, and then the type returns the data type. The pass statement. A function is not allowed to have an empty body. So to bypass this, we use the pass keyword, and it will not return an error. So for example, when you try calling an empty function, yeah, it will expect an indented block, it will return an error. So maybe you want to work on it later, you have to use the keyword pass. Yeah. Oh, yeah, I think I'm done. So, any questions? It's my first time teaching, so excuse me. Yeah,
No, no,
yeah,
no, no. You've done so,
yeah,
so, so good, Lewis. And you see, that's why I'm throwing this challenge to you guys.
yeah.
I'm intentionally doing this so that we can be able to find out where where you are good at. And you guys are really good. I believe Bobby and Benjamin can concur that you're doing a good job, isn't it, Bobby and Benjamin?
Yes, can you hear me?
Yes, yes, sure.
Yeah.
Yes, Tiffany and Lewis, you've done a really good job. That's commendable. So we'll keep using you guys. I think you're good teachers.
Yeah, definitely they are. And you see, if we just kept quiet, we didn't throw this challenge to them, then it wouldn't been fair. We wouldn't have been fair to them. So this also opens your mind, Lewis and Tiffany, and it also helps you gain confidence. So next time you become more confident. As time goes by, you become confident, just like that, and you become a better teacher. And the good thing that this is exactly the same thing that we did with the 2024 cohort. We gave them the opportunity, the platform to express themselves, teach whatever they've learned, and sometimes we would just give them maybe 5 minutes. It's basically what you've learned, how you've understood, and that's what's very, very important. And what really is the positive thing about it is that you, the person who is teaching, become a better person because you do a little bit of research. You go back to your notes and then see what did we cover, go a little bit deep, and then you come and then so it makes you a better programmer. All right. Yeah. So I'll invite now Catherine. So let's give Lewis thumbs up, please, as Catherine also takes the stage. She's gonna explain to us JIT. Yeah. And I'm sure, Elizabeth, you are anybody who is lagging behind. I think you're learning something, isn't it, Elizabeth? Are you learning something? All right, Anna, yes, I can see some. Yes, Elizabeth says yes. I think Elizabeth doesn't have a microphone. All right, so yeah, Catherine, please take the stage and continue from there.
Good evening, everyone.
Good evening.
You can hear me.
Sure.
Yeah, today I'm going to take you through the JIT, and I will start by introducing what is a JIT. A JIT is a distributed version control system where programmers easily track changes to their code, collaborate, and share. Then we also have a GitHub where
Sorry,
this
Catherine, do you have some PowerPoints to share with us so that we, as you go through, we also go through?
Okay, sorry.
Yes, please. Thank you.
Just a minute. You can see my screen.
Sure. Make it a little bit bigger. Make it a little bit bigger. Just like one more step. Reduce by one more step. Yeah, that's okay.
Like
That's
that.
okay. Yeah, that's good. Good enough.
Okay. A JIT is a distributed version control system where programmers easily track changes to their code, they collaborate, and they share the ideas. Then we have a GitHub. This is a storage space where you can manage your project files, including code, documentation, and other resources. A JIT is a version control, whereas a GitHub is a web-based application where you work online. Then here, a Git, the difference between a Git and a GitHub, a Git version control system that manage source code history, whereas a GitHub, a hosting service for Git repositories. And a Git has no user management feature. This is a command line where you just use a keyboard to type your commands, whereas a GitHub has a built-in user management feature. This is a you use graphic. It has a graphics that you use. It's called a graphica user graphic interface. So you can use
A
the
GUI,
mouse
a GUI. It's called a
yeah,
GUI, graphical user
yeah,
interface.
graphical user interface. Yeah, that is it. Then how it works, we have 4 sections when working with the Git. You have working folder. This is the current folder where you are working, where you are doing your coding. This is called a working folder. Then we have staging environment, where this is where the changes made remains until you add them to the local repository. So when you do your coding on IDE, it remains in staging area until you add them to the local repository. Then you have local repository. This is a repository that is cloned on your local machine. This is where you work and where you put your changes. Then we have remote repository. This is where after creating your code, doing your projects, you send your code now to the remote where others can have access to. That is remote repository. Then now we have the Git commands. The first command is Git version, Git dash dash version. This Git checks the version that you have installed on your machine, and you can do it practically. Let me open the Git. Just give me a minute. Can you see my Git? I don't know if it is too small. So we have Git dash dash version.
Make it big, Catherine. Control plus plus. And maximize it. Press the yes. Okay. Control plus plus again. And there's some noise coming from your background. Yeah, that's enough.
There is noise.
Yes, there's some noise coming from your background. All right.
Is it quiet now?
Yes, it is.
Okay. So this shows that my version is 2.47.0. This is the version that I was installed on my machine. Then we have git config dash dash global user dot name, then username in quotes. Here we should have quotes. This helps you to log into your Git version control system. When you put your username that you have registered with the GitHub, you have to register with the GitHub first before you log into the Git. So after registering to the GitHub, you will have a username and an email. You will also have a password. But when you want to log into the Git, you only need a username and an email. So I will log into my Git using my username. This is Git config dash dash global, then user dot name, then space, then the quotes. My username, I've created another account I want to use is Aji. Sorry, Aji. Then then like that. Then you
Yeah.
enter.
Just a minute. Just a minute. Sorry for cutting you short. Just to clarify something. What essentially you are doing right now, you are not logging in. You are creating your credentials. Okay, you are registering.
Okay.
It's like registering. You are, for instance, as a new Git user, you are registering your Git credentials. Okay, yeah, just to clarify things. All right, proceed on.
Okay, thank you for that. Then we input our email address that we registered with. So it is git config --global, then user dot email space quotes. My email is train 2030 at gmail.com. Then you close the quotes. So I will come now to back to the website so that I can, let me see the next command. Then you have git init. Git init, this is used to initialize the repository that you have created. So I'll come to my online account, then I will create the repository I want to work from. Then you can see here I have create repository. We also have this plus sign. You can use it to create repository. So let me create a new repository. And let me name it training.
Make it big a bit. That's enough. That's enough. Yes, yes, yes.
Okay, training. So we can now create our repository. Now this repository is on our remote. It is on our it is online. We have to put it on our local machine so that we are able to work on it. So I have to clone this repository to my local machine. So I'll come here. And copy this link. But let us come to another command first. Then we have git clone. So this one copies the repository from remote to your local machine. That is why I want to clone it to my local machine so that I am able to work on it. So we go to git. Let us initialize it. Then let us clone now. Git clone. So when I want to clone, I copy the URL. This one, I copy it. I paste it here. So it is cloning. So now my repository is now on my local machine. So I have to move into that local repository so that I can work on it. And we have a command for that. We have cd. Cd shows where you are working in immediately. So if I put cd, it means I'm just in main. Now I want to move to my repository that I've created. You use cd dash, then the repository name, which was training. Now, as you can see, I'm now inside the training. So when I'm now inside my repository, now I have to open the IDE to start my coding. So, and we have a command for that, which is code space, then period. So it is code space period or full stop. Now it is opening my IDE. Now, after my RTE is open, I have to add there something. I have to type there my code. I have to create my project there before I add it to my local machine. So as you can see, my IDE is open. I'm inside the training repository. So I can click here to create a file where I'll do my work. And I will call the file test dot html. Yeah. Now my HTML is ready to
Make
do
it
my work.
bigger.
Let me create a document called,
Make it bigger, please.
sorry?
Make it bigger.
Okay.
Control plus plus. Okay. And then you can remove the left
Is that
pane.
okay?
Yeah, just do Control B. Control B.
B.
Control
Okay.
B. Yes. Yeah. And now make it plus plus again. Yeah. One more. Yeah, that's
That
okay. Yes, that's okay.
okay, I want to create my profile in HTML file. So I'll put a heading there like Catherine profile. That will be my heading. And you can see this means untracked. So I have to add the changes I've made here to my local machine. Now we come to our next command, which is git add, then file name. Now because I've just made one, you can use git add then file name if you want to add that specific file that you have created or the specific changes you have made. But not because, or you can use git add to add everything, each and every change that you have made. You use git add to add it to the local machine. So for me, yeah, let me use git add.
You've missed the period. Git add space period.
Oh, yeah, true. When you want to add everything, you should add the period, git add, then period. Yeah, I think it has been added. And when we have also another command, which is git, oh, I did not add here, but we have git status, git status. This checks the status of your repository. If there are any changes you have not added to the local repository, it will show you. So for example here, let's do git status. As you can see, my repository is up to date. I have added everything because there is no red. So we come to next one. Git push. So let me add more things here. And here, each one. Then something like that. So I come here again. Let me add. So I want to push it to the remote repository. I use git
Before you push, Catherine,
push.
before you push, you need to
Yes.
commit it. You need to write a commit message. You've forgotten the commit command. Do you remember that?
Yeah. Also, commit comes before pushing.
Yes, sure.
Okay, so git commit. These are command to commit your changes. This here. It's git commit m. Then you write your message there, what you are committing. So it is git commit dash m. Then I write this.
No, the quotes.
9
You use the quotes, please.
4 5 7.
Yeah, yes, use the quotes. The quotes, the double quotes. Remove that stop sharing. Just hide that that tab that's blocking. Yes, it's blocking. Yes, now you can write your.
So I now push.
You can use the dash u flag. Git push space dash u flag. Go back with the back arrow.
Back arrow.
Yes. All right. Just type git push. Just type git push.
Git
Push space push. Yeah. Space dash dash u.
u.
Yeah. U. And then that's u for upstream, and then space. And then origin. And then your local repo is called main. So main, type main, because that's your local repo currently.
Main.
Yes, type main. And then enter. Oh, let me get my battery. Yeah, enter. Let me get my charger.
Error.
Error 403. This remote. Is it? Have you made it private or the permissions? I think isn't it? It's private, right?
It is trying to push to my other. It is pushing to my other account, and I'm using another account.
Oh yeah. Oh,
That is the problem. Because I'm using Aggie, and it is pushing to Cat. But once you push, your changes goes to your remote repository.
Yeah. So essentially,
then we have git log.
Just a minute. Essentially, what has happened? You are pushing to the wrong. You're pushing to the wrong. You cloned the wrong one. I think so. It's something like that. You must have cloned the wrong one. But what's important is that that's the process. What she's done is exactly how it's supposed to be done, and that's the process, irrespective of the fact that there's some permission issues over here. Yes, proceed on, Catherine.
Then we have git log. This checks the history, what you have committed, what you have done on your repository, and here it is showing me. I think that is my last command. Let me confirm. Okay, we have git pull. Git pull, it pulls the changes from the remote repository to your local machine. I think this is my last Git pull, unless there is any question or any contribution, if there is any command that I've forgotten.
Excellent. Wow. You guys are just something else. Good work, Catherine. Any question for her?
Thank you.
Yeah.
She has done a very great job.
Mhm.
I also, you've done a very good job that I feel bad telling you the one mistake you made. But on the command list, go back to your PowerPoint. There below git clone, where you've written cd for showing the current directory. There we don't use cd to show the current directory, current working folder. We can use dir to show where we are, which folder we are in, or ls, depending on which command line we are using. So if it's the command prompt, you use dir, or PowerShell, you use dir. And if it's the git bash that you are using, you use ls, and it will tell you for that. But for what you are trying to do to show the current working folder, you type pwd print working directory. But for now, what you've done is okay. We'll leave that one alone.
Yeah, excellent. Yes, I also thank you, Bobby, for pointing that out.
Thank you.
Based on where we are at right now, I think she's done a very commendable